So what we're going to be doing today is we're going to be talking about graphing quadratics using the x-intercepts. Now, we've had some, let's call it, experience doing this before. Now, when we talk about it, when we're talking about quadratics in intercept form, we're talking about this factored form that we used to call it. Remember, we used to call anything that is in this form, we used to call it the factored form. Now remember, we used to call that the factored form. We can also call that the intercept form. So I would suggest you add that to your jargon sheet. Now, remember that we talked about this yesterday. This, if I was looking at this equation, the x-intercepts would be x equals r and x equals s because of the opposite world concept that we talked about. And it would also work because of our zero concept we talked about. Now, we also call whatever we get for our solutions, we call them x-intercepts, but we also call them the roots of the parabola, i.e. the points that cross the x-axis. That is what the root of a parabola is, or a quadratic is. So to start today's lesson, we should take a look at this quadratic, and we'll see what we have here. So we have y is equal to brackets x minus 2 and bracket x plus 4 end bracket. So now let's just quickly find the x-intercepts by finding the intercept form and using that to describe our x-intercepts. We start like yesterday's lesson. We would say if we were just going to go and use the intercept form, we just go x is negative 2, x is 2, and x is negative 4. But when we want to plot the intercepts, you could also do this. So let's go and do that. So now we're going to say our first x-intercept is x is equal to 2. And we also have x is equal to negative 4. And normally we would write the following. So in this case, the x-ints are x equals 2 or x equals negative 4. And let's graph that. Okay. So our first point is negative 4, 0. And our second point is 2, 0, which we have to the right of the y-axis. Now you'll recall anytime we had two x-intercepts for any parabola, we had something akin to this for our parabola. If we had our two x-intercepts, say here and here, we could split the parabola along the mirror line, also known as the AOS. And what we did was we always just took the AOS as the average of the two x values. And so now what we're going to do is, when we're finding the x coordinate of the vertex, we're actually finding the AOS, the axis of symmetry. So you'll notice that we're going to add, and notice what I did. I put my two numbers for my x-intercepts into brackets so that I'm reminded that there might be negatives and positives that give us some issues. Now, when we do our calculations, we end up with x is equal to negative 1 once you simplify. So that's our axis of symmetry. Now, the next stage of our problem is to actually find the y coordinate of our vertex. To do that, we need to sub our axis of symmetry into our original equation, i.e. the x coordinate of the vertex. So we're going to start with our basic equation, then we're going to substitute directly in. So subbing in, we end up with the following. So we end up with negative 3 times 3, which gives us the y coordinate being 9. So this means that our vertex for our parabola is -1, -9. So let's go back to our original graph and plot that. So plotting that, we end up with our vertex being right here at -1, -9. Now, we could also go and find the x-intercepts and stuff like that, but we could also use the step pattern to find the rest of the points that we have for this parabola. Now, the a value for our parabola is equal to 1. Therefore, our steps are going to be 1, 3, 5. Now, if I go over 1 and up 1, this is my first point. If I go over 1 and up 3, my next point is going to be here. And now, if I go over 1 and up 5, my next point is going to be at 2, 0. And we're done. And remember, we have our axis of symmetry occurring right here, which means these points are mirrored directly across, so we can come up with a nice, smooth curve in the end. With beautiful matching points, and we end up with something that looks like this. And there's our parabola. The only thing that we have left to do is to label our axes. This is the x, this is the y-axis, these go on forever, and our equation, y is equal to x minus 2, x plus 4. Now, that's it. We got all the information we need. So what I'd like you to do is I'd like you to try the next problem and see if you can come up with the x coordinate for the vertex, and then I'd like you to try getting the y coordinate for the vertex and then plot the steps of your parabola and graph. And here we go. Now, I'm just going to go through this really quick. There won't be any explanation. We're not going to go through all the steps again, except for when we get to the step pattern that we have to follow. Now, when we've got something like this, if we set this equal to 0, we end up with -2, 2x minus 1 times 2x minus 3. So that means either 2x minus 1 equals 0, or 2x minus 3 equals 0. When we solve for x, we end up with 2x equals 3 for this side, and solving we end up with x is equal to 3 over 2. Do the same for the other side. 2x is equal to 1. Solving for x, x is 1/2. So now what we're going to do is we're going to take our time and we're going to graph those points on this really, really, really detailed chart. You'll notice that on the x-axis, everything is broken in halves. They're marked. It was deliberate that I did that. Okay? So you're going to be able to graph almost all the points that we need for this parabola. It's going to be hard to graph using halves and quarters for when we do our steps, but you can do this. Okay, let's go find the x coordinate now. and those 2 points. So there are our 2 points. The next thing that we have to do is we have to average those 2 points. S, our axis of symmetry. Going through the motions, we end up with this 1/2 plus 3/2, which gives us 4/2, which is really 2, and then divide that by 2 to get 1. So our axis of symmetry is going to be at x equals 1. And really, you could literally eyeball where the halfway mark between those 2 points is. Basically, the calculation is just to reinforce what you know. So now, when we go and calculate the y-coordinates of the vertex, we're just going to take our axis of symmetry for part C and we're going to sub that in to our original equation. Now you'll notice when I substituted, right? You'll notice that when I substituted into the brackets, I actually had to put my number 1 in a bracket there. Now that's because the coefficient in front of x is not 1. If it was anything other than 1, you got to put your stuff in brackets when you substitute directly in. So now simplifying, we're going to get this. Now 2 times 1 is 2, minus 1 times 2 times 1, which is 2, minus 3. Simplify, y is equal to negative 2 times 1 times negative 1. Which ends up being y is equal to 2. And that is the y value of my vertex, which means, if you think about it, the vertex with its x and y coordinates are 1 and 2. Now, looking at the original equation of our parabola, quadratic, you'll notice that the a value is negative 2. We expected our vertex to be on the top and the rest of the parabola opening down. And let's see if that's the case when we're graphing. So now let's get back to our plot. And it was 1, 2 as our vertex. Plotting that, we end up with this point here. 1, 2. Now, subbing x is equal to 0 in our, if we let x equal 0, we can get some more points to work with, so I don't really want to do any step pattern. If we let x equal 0 on our original equation, we get y is equal to negative 2, bracket, 2x minus 1, 2x minus 3. When we substitute in negative 2, if we punch in 0, we're going to get 2 times 0 is 0, minus 1 times 0 minus 3. And we end up with y is equal to negative 2 times negative 1 times negative 3. Wow, that's 3 negatives. So our y value ends up being negative 6. So now we've got another nice point to work with on our graph. So we plug that in. So this is 2. This is our position 2. This is our position 4. This is our position 6. So we'll just plot position 6. And now we'll mirror that point directly across the the axis of symmetry. And now there is our graph, and it's opening upside down, and we end up with this. And there's our graph. Our x and y axes are labeled. The only thing that we have to do is label our parabola. Y is equal to negative 2, 2x minus 1, and 2x minus 3 is our equation. And now let's move on to part 2 of this sheet.